Now we shift from AI cost and quality concepts into instrumentation. The goal is practical. Make agent actions traceable, tokens attributable, and outcomes measurable, so dashboards, chargeback, and governance are built on reliable operational evidence. So far, we've covered why agentic AI changes FinOps, what drives cost, and how to measure quality and value. This section connects those ideas to production telemetry. The observability architecture we build here becomes the foundation for accurate cost allocation and performance reporting teams can actually use. Traditional observability answers familiar questions. Are services healthy? Are requests succeeding? And where are errors or latency coming from? AI systems add another layer. An agent may plan, call models, use tools, retrieve context, retry, validate, and then respond. Each step can affect cost, quality, and risk. That means monitoring tokens and latency is not enough. We also need visibility into reasoning paths, model choices, tool behavior, safety, user outcomes, and spend. In practice, observability becomes the control plane for AI FinOps governance. A practical AI observability architecture starts by instrumenting every place decisions are made: the application, orchestrator, model gateway, tools, retrieval, and memory. Each step emits structured events, traces, metrics, and logs into a shared telemetry pipeline. The critical design choice is correlation. Shared identifiers such as trace, session, user, tenant, and workflow IDs let teams connect latency, cost, model behavior, quality signals, and business impact. Once stored for analysis, that data becomes operational. Dashboards show trends, alerts catch anomalies, evaluations review quality, and governance workflows support incident response and policy enforcement. Think of a trace as the full story of one user request, from the initial question to the final answer. Within that story are spans, the measurable steps the agent takes. One span might capture planning, another might record a model call, tool execution, retrieval search, validation check, or response generation. For agentic systems, this structure is essential. It shows where time is spent, where tokens and tool costs accumulate, and where failures or quality issues appear. Without spans, you know something went wrong. With spans, you know which step caused it. Agent workflows should be observable at the level of intent and control, not private reasoning. Capture structured signals such as the strategy selected, the number of subtasks created, the intended tools, and the agent's confidence. Then record the decisions that shape the path: model selection, tool selection, retries, fallbacks, escalation, or refusal. The key boundary is to avoid storing raw chain of thought or secrets. Use safe summaries, decision codes, and policy annotations instead. This gives teams enough visibility to spot loops, excessive tool calls, bad routing, and workflows that are starting to run away. Every model call should produce a structured telemetry event. Start with what was called provider, model, version, region, endpoint, and key parameters like temperature and max tokens. Next, capture token economics: prompt tokens, completion tokens, total tokens, cache hit, and estimated cost. Add reliability signals such as latency, queue time, timeout, error code, retries, and any fallback model. Finally, attach business context: application, tenant, cost center, user segment, policy profile, and task type. Together, these fields turn raw LLM traffic into accountable FinOps data. When an agent fails, the issue is often not the model call itself. It is the work around it. Treat every tool execution, retrieval query, and memory operation as its own trace span. For tools, capture the name, input size, duration, status, retries, error codes, and any external cost. For retrieval, record the index, query type, documents returned, ranking scores, embedding model, latency, and cost. For memory, log reads, writes, store, payload size, retention policy, and whether memory affected the answer. This makes hidden bottlenecks and poor context visible. Telemetry becomes useful when every request speaks the same language. For tokens, capture input and output, plus total cached reasoning tokens when available, and the limits applied. For cost, record the estimated charge along with provider, model tier, pricing version, currency, discounts, and assumptions. For latency, separate total request time from model time, queue time, tool calls, retrieval, and full task duration. This consistency turns raw logs into governance data. It lets teams compare models fairly, allocate spend by tenant or workflow, detect anomalies, and build dashboards people can trust. Agent latency is the sum of many small weights, and those weights can amplify. A single request may spend time planning, retrieving context, calling a model, using tools, validating output, and coordinating the next step. Break total time into spans, then compare typical latency with tail latency, P50, P90, P95, and P99. Tail spikes often come from retries, fallback models, oversized context, slow tools, or network delays. Once the source is clear, optimization becomes targeted. Cache repeated work, route to faster models, compress prompts, parallelize steps, or tune retrieval. Reliability telemetry should follow the request through every recovery step. Start by recording the original failure in structured form. Type, code, provider status, timeout, safety refusal, or validation issue. Then track what the system did next. Did it retry? Did it switch to a fallback model? Each extra call can add latency and multiply token cost while masking the root cause. Cache data matters as well. Hit or miss, cache type, tokens reused, freshness, and estimated cost avoided. Finally, connect these signals to task success, feedback, policy outcomes, and support escalations. Raw traces tell you what happened. Quality signals tell you whether it was good. Attach user feedback directly to the response span. Ratings, comments, satisfaction, or complaints. Add automated evaluation scores for accuracy, groundedness, relevance, safety, tone, and instruction following. Policy systems contribute violations, refusals, moderation results, and compliance flags. Human review adds escalation outcomes and judgment, where automation is uncertain. Task success labels then connect the trace to the real goal. Together, these signals turn observability from debugging data into a measurable view of agent performance. FinOps for AI is not a race to the cheapest model. The goal is to understand what each dollar buys. A useful metric ties spend to an outcome. A successful task, a resolved case, a conversion, an avoided escalation, or a high-quality answer. Segment those numbers by model, agent version, tenant, workflow, and task type, and patterns become clearer. Some flows are expensive and weak. Some are fast but inaccurate. Others deliver quality, but with unnecessary premium model usage. Correlated telemetry turns these trade-offs into decisions about routing, prompts, caching, thresholds, and governance. Governance-ready observability means every signal is useful, safe, and accountable. Start with standards, structured logs, consistent metric names, trace context, and shared resource tags, so data can move across tools. Protect sensitive information with redaction, hashing, encryption, access control, and clear retention rules. Be deliberate with sampling. You can reduce high-volume noise, but keep the events needed for cost analysis, quality review, incidents, and audits. Finally, connect telemetry to cloud and FinOps systems. That turns observability from a debugging tool into an operating model for monitoring, chargeback, compliance, and continuous optimization. AI observability gives teams the operating system for governing agents. By tracing plans, model calls, tools, retrieval, memory, validations, retries, and responses, and by correlating cost, latency, errors, cache, and quality signals, you create accountable telemetry. Next, that telemetry becomes allocation, chargeback, and reporting, connecting AI spend to owners, workflows, products, tenants, and outcomes.